Hello children, today we are going to cover thermodynamics, few topics of thermodynamics. Spontaneous processes are those that can proceed without any outside intervention. The gas in vessel B will spontaneously fuse into vessel A, but once the gas is in both the vessel, it will not go spontaneously. Processes that are spontaneous in one direction are non-spontaneous in the reverse direction. Processes above 0 degrees Celsius, you can see it is spontaneous for ice to melt. But below 0 degrees Celsius, the reverse process is spontaneous. Reversible processes. In a reversible processes, the system changes in such a way that the system and surrounding can be put back in their original states by exactly reversing the process. Changes are infinitesimally small in a reversible process. These are some irreversible processes. Irreversible process cannot be undone by exactly reversing the change to the system. All spontaneous processes are irreversible. Entropy can be thought as a measure of the randomness of the system. It is related to the various modes of motion in molecules. Like total energy E and enthalpy H, entropy is a state function. Therefore, delta S is equal to delta S of final minus delta S initial. For a process occurring at constant temperature, an isothermal process, delta S is equal to Q reversible upon T. Q reversible is heat that is transferred when the process is carried out reversibly at a constant temperature. Second law of thermodynamics. The second law of thermodynamics, entropy of the universe does not change for reversible process and increases for spontaneous process. जैसे हम रिवर्सिबल के लिए बात करते हैं, डेल्टा एस ऑफ यूनिवर्स इज इक्वल टू डेल्टा एस ऑफ सिस्टम प्लस डेल्टा एस ऑफ सराउंडिंग एंड दैट इज इक्वल टू 0. For irreversible or real spontaneous process, delta S of universe is equal to delta S of system plus delta S of surrounding should be greater than 0. If we will see entropy on a molecular scale, implications क्या क्या हो सकते हैं? More particles, more states, more entropy. At higher temperature, entropy will be more. Entropy increases with the freedom of motion of molecules. Therefore, the entropy of gas is greater than the entropy of liquid, is greater than the entropy of solid. Dissolution of a solid ions have more entropy, more states, but some water molecules have less entropy when they are grouped around ions. In general, entropy increases when number of molecules increases. Gases are formed from liquid and solid, then we can say entropy increases. liquid or solutions are formed from the solids, then we can say the entropy increases. The number of gas molecules increases, we can say the entropy increases. The number of moles increases, then you will say entropy increases. Now next thermodynamic quantity, Gibbs free energy. If delta G is negative, the forward reaction is spontaneous. If delta G is 0, then the system is at equilibrium. If delta G is positive, the reaction is spontaneous in the reverse direction. Standard free energy of formation are analogous to the standard enthalpy of formation. Standard delta G of formation is equal to total delta G naught of reactant minus total delta G naught of the product. Now we can see the equation delta G is equal to delta H of system minus T delta S of the system. Very key equation of thermodynamics. This equation shows how delta G naught changes with temperature. There are two parts to the free energy equation, delta H naught and T delta S naught. Delta H naught the enthalpy term, T delta S naught is the entropy term. By knowing the sign plus or minus of delta S and delta H, we can get the sign of delta G and determine if the reaction is a spontaneous or non-spontaneous. डेल्टा जी नॉट को अगर हम इक्विलिब्रियम कांस्टेंट के साथ रिलेट करें, डेल्टा जी नॉट इज इक्वल टू माइनस आर टी एल एन के, where k is the equilibrium constant. Delta G is 0 when the system is at equilibrium. Delta G must be related to the equilibrium constant, the standard free energy that is linked to equilibrium constant by delta G naught is equal to minus RT ln K. Thank you very much. Next we will discuss in some other video. Delta G naught is equal to minus RT ln K and delta G is equal to, we can write delta G naught plus RT ln Q, where Q is the reaction quotient. At equilibrium, delta G is equal to 0. Always from equilibrium, sign of delta G tells which way reaction goes spontaneously. Under non-standard condition, we need to use delta G instead of delta G naught. Thank you. That is more about, let us discuss some other topics in next class.